Hey guys, in this video we're going to talk about solving quadratics by factoring when a equals 1. We're going to talk about what a quadratic is and why we would factor them. Let's talk about what a quadratic is. A quadratic is an equation with an x squared. And typically, we see them in the form that we see here, ax squared plus bx plus c. But one term can be missing out of these quadratics. A and b are often considered coefficients of the quadratic. They're called coefficients because would be numbers here that are in front of the x variables. C is referred to as the constant or the number by itself, and all of this equals y, which is the output, and x is the input. Quadratics are known to be graphable functions that are very applicable. In a later video, we'll talk about graphing quadratics. I placed the first example over the standard form, which we just looked at. In this case here, there's a secret little 1 in front of that x squared. What that means, if we line this up, take it the way it looks, a equals 1, b equals -5, c equals -24. A and b are the coefficients in front of x. C, or -24, is the constant. Typically, when we solve quadratics, not always, we need to have the quadratic set equal to 0. There is a method to solve quadratics without setting it equal to 0, but we're not going to do that in this video. So we're going to solve this problem through the process of factoring. What we have to do when we factor is we have to figure out what multiplies to the constant, or in this case 24, and what adds to the b term. Typically, I will say what multiplies to c and adds to b. So the way we're going to do this is we're going to find the factors of 24. I often see students of all levels try to work out these factors in their heads. I don't think that's wise. Oftentimes, a very common mistake that students make is they don't write something down thinking they're going to save time, but in fact spend more time, or in worst case scenario, make an error. So what I'm going to do very quickly is I'm going to write out the factors of 24. This is also a great way to get control of your times tables if you struggle with that. I am going to count to 10 on the left side here, and then I'm going to divide one by one into 24. So 1 divided by 24 is 24. 2 divided by 24 is 12. 3 divided by 24 is 8. 4 divided by 24 is 6. 5 will not divide into 24 evenly. 6 will divide into 24 by 4. Now, if you notice, here and here, I have found all the factors of 24 because the numbers have repeated. That's how I know I found all the factors. So, I very rarely actually have to go all the way down to 10. Now I'm going to figure out which of my factors will add up to 5 or -5. Well, let's see. 1 plus 24 will not add to 5. That will be 25. 1 minus 24 will be 23. So I will not use 1 and 24. 2 and 12. I cannot add those to equal -5 either. 2 plus 12 is 14. 2 minus 12 is -10 or +10. 3 plus 8 equals 11. But 3 minus 8 equals -5. Or if you needed the 5 to be positive, 8 minus 3. So 3 and 8 are the factors we're looking for. So my next step is to set up two sets of parentheses and place x's in both because I have an x squared there. And now what I'm going to do is place my factors. So I said 3 minus 8 gives me negative 5. So that means 3 is positive and 8 is negative. Oftentimes I get this question, how do you figure out the signs in the parentheses? Well, the answer to that is you want to combine these two constants or these two numbers to equal the b term. So you want a negative 5. You want b to be negative 5. So 3 plus negative 8 is negative 5. I want to show you one more thing here before we move on. Okay, this here is called factored form. I have factored my quadratic. Another way to look at factoring, it is a form of division. What I can do here is I can multiply these back together using the distributive property like we talked about in the previous video and combine these two sets of parentheses to put this back into standard form. So I'm going to do that real quick. So x times x is x squared minus 8x plus 3x minus 24. I'm going to combine my like terms here, and I'm going to get that negative 5 that we were after, because negative 8 plus 3 is negative 5x minus 24. Another way to look at this is that we are converting between factored form and standard form and back again. Part of the reason why we're looking at so many points of view here on factoring quadratics or solving quadratics is because they are very applicable, and this different language arises depending on the application. Quadratics can be used in a lot of different places, and part of the reason is because they can be simply converted and moved around. Now, with all that being said, I actually did not finish the problem. It says here, solve the quadratic by factoring, so I need to solve. That means I have to have or know what x equals. The way I'm going to do that is I'm going to set both of these equal to 0. So I'm going to set x plus 3 equal to 0 and x minus 8 equal to 0. Then all I have to do is solve for x. Typically do by using the inverse operation. Now you'll notice that there's two solutions here. We will talk about this again when we talk about graphing quadratics, but essentially what's happening is this equation will pass the x-axis on a graph twice. So therefore there are two x's. Alright, let's look at the next example. Okay, so in this example I notice immediately that a does not equal 1. But thankfully, each of these terms are divisible by 4. So what that means is I can divide all three terms by 4. So I'm going to do that. And the reason why I could do that is because I'm maintaining equality, I'm dividing all the way across. Now keep in mind, the 4 is not really kind of going away. This is similar in nature to the idea of reducing fractions, is one way to look at it. Another way to look at it is that I am taking this 4, dividing it out, and then I'm dividing it into 0. And so therefore, 0 divided by 4 is 0. Now I'm going to factor just like before. I'm going to write out the factors of 3. Students often get confused about this problem. So there's only one factor of 3, 1 and 3, because 2 will not divide into 3, and then 3 gives me back that 1 again. So my factors have repeated. I have found all of the factors of 3. 3 is a prime number, so there's only one number that divides into it other than 1, which is itself. Okay, so now I have to figure out how to get those two numbers to add to negative 2. Well, 1 minus 3 is negative 2. 3 minus 1 is positive 2. I want negative 2, so I'm going to set up what's often called as the double bubble, and then get my two x's in there. 1 minus 3. So I'm going to have a positive 1 minus 3. A question I often get is, does it matter which direction or which order we write these bubbles in? And the answer to that is no, because they're multiplying. Now, just like before, I'm going to set these both equal to 0 because I am solving. So I'm going to subtract the 1. My first solution is negative 1. This is one solution here. Then I'm going to add the 3 and the x equals 3, and that is my other solution. Alright, let's take a look at the next example. In this example, I cannot factor. The reason being is because this quadratic is not set equal to 0. So what I'm going to do is I'm going to set this equation equal to 0 by doing the inverse operation here and adding this 3x squared to both sides. The reason why I'm adding is because I want to have a 0 here. Keep in mind that 3x squared is not going away. It is combining with something else. So negative 3 plus 3 is 0. That's what I was after. And negative 2 plus 3 is x squared. So conveniently, I now have a factorable quadratic. I'm going to write out my factors of 12 to figure out which ones will add to negative 8. So 12, 1 and 12, 2 and 6, 3 and 4, 4 and 3. Great, I found all my factors. Keep in mind, if you're not that comfortable with your times tables, use a calculator. Over time, this will become faster and faster because you'll gain that experience with your number tables. So now, I want to add to negative 8. Well, let's see here. This one's a little bit tricky. 1 plus 12 is 13. 1 minus 12 is 11. So, negative 11. That's not going to work. But 2 and 6. 2 plus 6 equals 8. But I need them to be negative. So, negative 2 plus negative 6 will give me negative 8. So negative 2 and negative 6 are the factors I'm looking for. We always want to focus on how to get to the total of b. That's how we're going to figure out what our signs are. That's where we're going to figure out how, what factors to use. Now, from there, just like before, because it says find the zeros. So that's just another way of saying solve for x, or as I mentioned earlier, find where the quadratic crosses the x-axis. So I am going to set this equal to 0, add the 2, and I have x equals 2. That is my first solution. X minus 6 equals 0, add 6, and x equals 6. That is my second solution. Just remember, it doesn't matter which solution is first or second. We just want to know what x equals in the instance of this quadratic, or, as I mentioned, if we were to graph this quadratic, we would like to know when it would pass the x-axis. Alright guys, I hope you guys found this video helpful.